Hey YouTube, welcome back to another video in my LeetCode series. In this tutorial, I'm going to be teaching you how to remove duplicates from a sorted array. And this problem is pretty controversial. We have 12,000 likes compared to 16,000 dislikes. So the community is pretty divided on this one, it seems like. But the reason I chose this problem is because it's an easy problem. And secondly, it deals with arrays. So I want to go through each data structure one at a time in this series. So I'm going to be going through all the problems hopefully, but we're going to start off with the arrays and then we're going to move on to another data structure later. So I'm going to read this problem for you and then I'm going to summarize it later. So it says, given an integer array nums sorted in non-decreasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same, then return the number of unique elements in nums. Consider the number of unique elements nums to be k. To get accepted, you need to do the following things. Change the array nums such that the first k elements of nums contain the unique elements in the order they were present in nums initially. The remaining elements of nums are not important, as well as the size of nums. And then return k. So basically what it's saying is that you need to return a sorted array, but it only really needs to be sorted within the first k elements. So you could have 1, 2, 3, 4, 5, and then you could have, I guess, 1 and 3. But as long as you return k equals 5, you should be okay because the first 1, 2, 3, 4, 5 elements are sorted, or at least that's what I'm getting from this. So there's a lot of different ways you could go about solving this problem. What I decided to do wasn't necessarily the best solution, but I'm going to show it to you anyway, and then I'm going to show you the best solution for this problem. And if you want to just skip to the best solution, I'm going to put a timestamp right here, and you can just skip ahead. But if you want to see the other solutions and how I went about solving it, just keep watching. So basically my thought process was, what if we had some sort of bin? And what if we could go through each element in our array and we stored it in this bin? So my thought process was, what if we could loop through this array and then we could mark each element as seen or unseen? So is it in the bin or is it not in the bin? And then if it is in the bin, we know that we found a duplicate and we can remove it and we can move on to the next element. And then we keep following that process until all the duplicates are removed and we're left with an array that has nothing but unique values. And we don't need to sort these unique values because we know that they're already sorted. And so what did I decide to use for my bin? Well, I decided to use a hash map. And that was just my inexperience with LeetCode. A hash map really wasn't the best data structure to use. And I'm going to show you a better data structure to use later. But let's see how you can do this with a hash map first. So I'm going to define a new hash map. So I'll say let map equals new map. And then I'm going to define k because as the question states, you have to return k, which is the number of unique elements in nums. So I'll set k as 0. And now I'm going to start looping. So for I equals 0, I is less than nums.length, increment I. Now after we've made our loop, we're going to see if our map has nums.I. So have we already seen this element? And if we have already seen it, we can cut it out of the array. And we use splice for that. And we'll cut it out at the index, and we'll put 1 because we're removing one element. And then if we haven't seen it, we'll set a key value pair. With the value as the key and the index as the value. And that should work, right? Well, it actually didn't work. We only passed 100 out of our 361 test cases. Now, let me tell you why. The reason for that is because every single time we cut out or splice a value from our array, what happens is the index automatically increments because that array is now shorter. So we only want to increment when we set a value, because this is already incrementing, so we don't need to increment twice. Now if we submit, you'll see that our solution was accepted, but we only beat 16.53% of users with JavaScript, which is pretty bad. So how can we improve this? Well, first of all, like I mentioned, our bin right now is a hash map, and a hash map contains a key and a value. And right now we're only using the key. So there's no reason to be using a hash map at all. That was just my mistake, but I just wanted to show you my thought process. A different way or a better data structure we could use is a set. And a set only stores unique values. So instead of let map equals new map, I could say let set equals new set. And instead of map.has, I can say set.has. And instead of map.set, I can say set.add nums I. Now if I submit, you'll see that this solution is even worse. We only beat 18% of users with JavaScript, but it just goes to show that you really don't need to use a hash map when you can use a set. So what I realized from here is that we're going to need a completely new approach in order to solve this problem. Because right now this is running super slow. We're only beating 18% of users with JavaScript. So I'm going to show you a different approach for solving this problem. Alright, so one thing I actually forgot to mention was that I defined k right here, but we're never returning it. And the reason we return k is because the question asks us to return it, and basically what k stores is the amount of unique elements in nums. So all we have to do is plus k here, and then right here we can return it. And if I submit, you'll see we get the same answer. One thing that I just realized is that every single time I submit, I get a somewhat different runtime, and it beats a different amount of users with JavaScript. So nothing really changed here in terms of the time complexity. It's just something I'd let you know. But with that being said, let's move on to the best solution on how to solve this problem. So I'm going to delete all of this code right here. And what I'm going to teach you is the two-pointer approach. So let's say we have an array like 1, 1, 2, 2, 3, 3, 4, and 5. Basically what we're going to do is we're going to set one pointer, which is going to be k, and we're going to set k equal to 1. And k is going to point to the first element in the array, not the 0th element, but the first element. And the reason for this is because we know that the first element is going to be unique. And now we're going to have our second pointer, which is going to be I, which is also going to be in the first spot. What we're going to do is we're going to increment I, and every time I changes from the value it was before, we're also going to increment k, and then we're going to pass this value of I down to where k was. Let me show you again. We're going to increment I. It doesn't change from the previous value, so we're going to increment it again. Now it changed. I is pointing to 3, when before it was 2. So what we do, we update this value, which k is at, to 3, and now we increment k. Now we move I forward again. It's the same as it was last time, so we'll move it again. Now I points to 4, which is different from last time, so we update that value of k to 4. And now we move k forward. Now finally, I moves to 5, which is different than it was last time. So we set the value of k to 5, and then that's the end. And we return k because, like we said, it doesn't really matter if the entire array is sorted. We only need the first k elements to be sorted, and the first k elements has to be all the unique elements in the array. then we're going to return k to let the testing system know that the unique elements end here, basically. So how would I code this? First, I'm going to set k equal to 1. And then I'm going to make another for loop. So for I equals 0, I equals 1, I is less than nums.length. We're going to increment I. Now we're going to do our first check. We're going to say if nums of I is not equal to nums of I minus 1, then we're going to set nums of k, our second pointer, equal to nums of I, and we're going to move k forward. And then all we need to do after that is simply return k. Now if I submit, we'll see that our solution beats 71% of users, which is a lot better, and we did it in fewer lines of code. Alright guys, so that wraps up everything for today. I hope you learned something from this video. Make sure to like and subscribe, although you don't have to, and have a great day guys.